Today's quiz is centered on the transistor, a quantum mechanical device that is ubiquitous in our world at this point. But before we get to the transistors, I want to tell you about this circuit and where this quick quiz came from. Back in the day when I was in high school, if you went to shop class, everyone had to wear safety glasses. Unlike today where you can order things off Amazon fairly cheap, safety glasses were expensive and they were used year after year. So you might have 8 classes in a day, and so those safety glasses would get used by many, many students. But you didn't want to transmit any kind of eye infections or anything like that. So they would clean them, not by rubbing them with alcohol or soap or water or whatever. What they would do is they would take them when you were done, and they had a big cabinet that would open, and you'd always put your safety glasses back into the container or the cabinet. And then as you shut the doors, a big light would come on. It was a germicidal light, and it would give off high frequency UV, and it would essentially kill all the bacteria. As a young lad, I always thought, how does it know when to turn on? And that's what our quiz is going to be centered on today. And we're going to use a circuit that looks just like this. Now, first of all, I want to introduce something else. This is called a photo transistor. And what it's going to end up doing is it's going to allow us to take a little bit of the light just in the room here. And as it gets more or less light, it's going to end up allowing more or less current to flow through it. So we're going to put the two together. And one of the things that you can think of, if you're not familiar with transistors or you haven't used them in a while, is they can act like little amplifiers. Our circuit behind us shows that we have a battery, and here is going to be our relay. And a relay is an excellent device for allowing us to separate different power supplies. I'll show you in a second. Here's our little photo transistor, and notice we have 2 arrows going towards it. So we're going to essentially use the light in the room, or the amount of photons landing on this, as being our base. From there, we can go to the base of this transistor, and look, our power is ready to go through this coil, which is going to be on our relay. Now, once this coil is activated, you could see that this switch can either be pulled down or left open, however you'd like. But regardless, from there, I can use a whole nother power supply, right? So essentially what we're going to end up having is a little bit of signal here from the light in the room, and when that essentially goes dark, we no longer get the signal that we had before. The transistor will amplify that signal. And just so you know, even a standard NPN transistor used on a very small circuit board like this can amplify somewhere between 100 to 1,000 times. Let's just say about 100 would be a reasonable value for amplification here. And then we can end up using our relay. Let me explain what the relay is all about. See, my circuit right here is going to work on just a few volts. I could use a small little battery if I'd like, maybe 2 AA batteries or something like that would be sufficient to run the circuitry. But to run that big germicidal bulb, which I'm going to simulate with this high voltage bulb over here. Now I'm running it at half voltage, but it's still using 125 volts. That's where we want the relay. I've got 125 volts running this big bulb right here, and yet I have almost or very low voltage running the brains of the circuit here. So that's why we want to separate them. Let me show you how this works. Once you have this configured, I can end up taking and blocking the eye. So right now, the doors to the cabinet would be open. But if I were to blacken it, and we'll pretend like it's going to end up being dark, now the bulb turns on. And of course, I'm running this at half voltage because I don't want it to blind the camera. And then when I open it up, it would shut off. And as we shut the door, and you can make this as sensitive as you'd like. In fact, my hand could probably set this off. I think you can see. All right, I'm going to shut this off because I really do have high voltage going across here, and I don't accidentally want to touch it. So you could hear it shut off. Our quiz for today says, look, this circuit is theoretically going to be great, but it's not. It's not enough. This is a heavy-duty relay, and that relay is going to take a lot of current to energize. And this one transistor just isn't sufficient to do that, okay? In other words, I put on a certain amount of voltage or current for a BJT transistor, and it allows this gate to essentially have current flowing through here. But it's not quite enough. So our question today is, if we give you a second transistor, one of these NPNs, it's identical, could you then put it into this circuit so that we could get enough current here? So let's say that we're amplifying this small little signal right now by, let's just say 100, which would be really nice. Let's say that we want to amplify it to be 10,000, another 100 times. How would we put this transistor, represented with our 3 leads here, into this circuit? Here's what your quiz looks like for today. Let me open it up so you don't see a double image. All right. We've left plenty of room for you to redraw the circuit or parts of the circuit that you'd like, and then when you're done, mark your confidence. Typical student responses will be, I bet it's going to be wired in series or parallel. And the answer is, of course, yes. However, they're thinking about that. But it's not that easy to think about series and parallel with this circuit. So I would encourage them to draw it out as much as they can. Now, some of them are going to ask and say, could you help me again with the base, emitter, and collector? And you could say, yeah, the base is kind of like the gatekeeper telling the gate either to open or close. And you can say the emitter is where electrons are emitted and they collect over here. Or if your students have learned conventional current, you could say, well, it goes from the collector to the emitter, and the base is kind of like going to be the valve for that system. Once you give them those, a couple hints, and maybe whatever else they need, get them to try to focus in on this part of the circuit and see what they can draw. A good hint to give students is saying that, look, the single transistor took that signal and amplified it. How could we take that new signal and amplify it more? That's a pretty big hint. See if they'll take that, and they'll come back and explain this. All right, let's go ahead and explain the best way to take care of this circuit. Look, each one of the transistors is going to amplify. So this signal has just been amplified. So what we're going to do here is we're going to take this straight out, and we're going to put it into, instead of going to ground, we're going to, I should have left that there. We're going to end up putting that right into another transistor. So we'll go right here. We'll put this line here. We'll call this the base of the next transistor. And then we'll have our lines coming in like so. And we'll make this our second transistor. We'll put our little triangle here like so. And then we can end up saying, well, that's going to be our new collector here. And this would be our new emitter. And then I can draw this so it looks like a transistor, like this. So we have one transistor going right into the other transistor. Now from here, we can end up modifying this just a tad bit. We'll take this, make our new lead come down. We can end up ridding ourselves of that wire. We'll just extend everything out just a little bit. So this one is going to come out here like so. I'll have this one come out like so. And then I can collect all of them together. So I'll take this from here down here, come out, something like that. And now we've got one transistor that sets off another transistor. The one portion that they might be a little confused about is, what do I end up doing? Oh, these are backwards, by the way. This is an emitter. That's collector. So this is going to be our emitter, and that's going to be our collector. And then we can just take this collector and connect it over with our other, just like this. So now we've got this one transistor that's going to amplify, and we're going to take the new signal coming out of here right to another transistor and amplify it again. Now, this is nothing new. We call this configuration a Darlington configuration. Okay, a Darlington configuration. So whenever you see two transistors like this, that's what we're doing. We're trying to amplify twice, and it happens all the time. All right, let me show you one other thing. Okay, I have my circuit here and I'm at the table. Here is my little photo transistor right here. There are my two NPN transistors. And here is my relay right here. And that relay we'll be able to see click on and off. But let me just use one of the battery caps and close off our circuit. And you can hear and hopefully see right here that our relay is working. Maybe I can put it to the side and hopefully you can see the switches inside here moving. Let me hold that and see if I can cover this. It's a little bit more difficult to do. All right, so that's what it looks like up close. And you'll notice that I just have, just like I have over here, I have one transistor and then I put a second one on here. Not a big deal. So this is a circuit that you could easily build. But what I wanted to show very quickly is that I could either put the relay on the high side up here, or I could have put that relay down here on the low side. And just to show you the difference, this one right here is actually on the low side. In other words, I have it down here going right to ground. I don't know if you could see this brown wire. That's my ground wire. So in other words, once the signal comes through here, the coil then goes to ground. But if I were to take this off, and I have one built that's identical, I have, this is going to be my negative, and then I'll make this one my positive. And then I'll take my relay, pop this out, and I'll just put it right over here. So you probably heard it click in there. And now I can have this one working. This is how our diagram is made. This is on the high side. Now, the reason why I'm showing you this is because you can do it either way. They'll both work with these sets of transistors. In fact, almost everything on this circuit and this other circuit are identical. It's just where you put your coil. Now, as you go in to these in a little bit more depth, you might notice there's some slight differences in how quickly they react or how long it takes them to relax. But those are two terms that we might want to start thinking about, high side and low side. And because this is such a simple circuit, I thought this might be a really nice time to bring these two in. All right, let's go back over. Okay, that's our circuit and how it's built. Make sure this one's still working. And you really don't need many components here. Couple conclusions. First of all, if you build a circuit and you're like, it's supposed to work, that's a 5-volt relay and I'm using about 5 or 6 volts and it's not actuating, it might not be that your circuit's wrong, it might just not have enough juice. So consider using a Darlington and amplifying your signal even more. Another thing you might want to try is maybe you've made a high side circuit and for whatever reason, the electronics just don't line up and it's got characteristics that are going to give you a problem. Consider before giving up making a low side. Often you switch them and everything works fine. It just happens to be the ranges of each one of your components just happens to align better one way than the other. So this is a nice circuit to start thinking about. Don't play with high voltage, but if you ever need to have a low voltage and a high voltage, a relay is a wonderful device for separating two circuits using a magnetic field and magnetism to actuate the other one. All right, that's a lot of information in one quiz, so let's call it a quiz.